Hello guys, welcome back to the next lecture of learning advanced DSA in Python, and today we are going to learn about very important data structure called as linked list. Data structure. Now if you don't know about what is data structure, think like they simply tell us how data will be stored, how data will be stored in memory, how data will be stored in memory of your computer, how the data will be stored. Okay. Because there are many data, right? Suppose you have data 10, 20, 50, 60, how they will be stored, right? This data structure tells us. We have a list where the data or individual items are stored like this: 10, 20, 30, 40. Like we have already seen it. We have tuple, we have dictionary, right? They all are data structure which tell us how all these data will be stored in the memory of your computer, simply. And linked list, it is also one of the linear data structure. Another very important point, linear data structure, like just like list and all. It is a linear data structure, meaning that elements are stored sequentially. Elements, or I can say individual items are stored sequentially, right? In any data structure where elements are stored sequentially, we call them as linear data structure. And when we talk about a linked list, here also the elements are stored sequentially, one after another, like this in a sequence, right? Hope it is clear. But what it is, what linked list actually is, that's a big question mark. What it actually is, right? So you can think linked list of a linear data structure where elements or individual items are stored in a separate object. Every element will have a separate object, guys, here, right? Separate object. And what that object is called, you can call it a node. Very, very, very important concept of linked list, right? What did I say? Every element, for example, 10 is an element. It will be stored in node like this. Then 20 is another element. It will be stored in another node like this. 30 will be stored in another node like this. So every element will be stored in a separate object, right? Now, unlike list or array, unlike list or array, they are not stored in a contiguous memory location or next to each other. How elements in array is stored like this: 10, 20, 30, like this, correct? In a contiguous memory location. If, say, suppose element 10 is stored at memory address 1000, then your 20 will stored at 1001, 30 will stored at 1002, and so on. In a contiguous memory location. Contiguous meaning next to each other. Contiguous meaning next to each other. The elements are stored next to each other. Next to each other in a list or array. List or array. But in linked list, they are not stored in next to each other, right? They are not stored next to each other. Elements are not not stored next to each other. Very, very important. Then how they are stored? How they are stored, guys? Next to each other. They are stored in nodes, as I told you, like this. 10 will be stored in this node. 20 will store in another node. It's a separate object. 30 will be stored in another node. Now, this node is a separate object. Let's call it as node 1. This node is a separate object. Let's call it as node 2. Then this node is another object. Let's call it as node 3. Let's say this node 1, it's a complete separate object altogether. It's a separate object altogether of node class. And how to create node class, this we will see. Suppose its memory address is, you can say, 1000. Then this node 2 can be 5000. Then node 3 can be your 2000. They are not stored in contiguous memory location like list. Here the elements are stored in 1000, 1001, 1002. This is the main difference between list and linked list. Very, very important interview question. List versus linked list. Of course, they will not ask the theory. They will give you the programs, but you should have the concept clear in your head. Okay. Okay. So the first element in linked list will be stored in a separate node. Second element will be stored in separate node. Third element will be stored in separate node. Okay. And they are not contiguous next to each other. Node 1 is at 1000, node 2 at 5000, node 3 at 2000. Okay. But then remember there is one thing which is written here linked. Linked. In list, we have linked. That's why we called as linked list. Then how they are linked? How they are linked? Node 1 will know the address of node 2, guys. Node 1 will know the address of node 2. So in node 1, this is 10 is your data, and the another part of the node 1 will be your address of node 2. Address of node 2 or pointer or reference. What is the address of node 2, guys? This is 5000. So 5000 will be stored as the second element, which we called as the address of the node 2. So it will be linked like this because this is a reference. Node 1 is a reference or pointer to node 2. Simply, node 2 will also store the address of node 3. This is how they are linked. Every node has two elements, data and address. Data and address. So node 2 will store address of node 3, which is your 2000, and so on. Then node 3 being the last node, it will just have null at the end. In a linked list, the last node address will always be null, like last node. When we talk about singly linked list, now we will quickly see the types of linked list soon. Like, but for now, understand what is a node now, right? What is a node class or rather node class? Node class contains two things, guys. Data, where the elements are stored, where the elements are stored, elements are stored. Then your second part is address. Address and whose address? Address of next linked node. Address of next linked node. Right? So this is how your node looks like, guys. A node, a visual representation of a node is like this. This is your node, entire node. And here your in this node object, your element will be stored 10 and address of next node. For example, 5000. This is address of next node. Address of next node. And this node will also have some address, right? This node will also have some address. Node, right? The very first node, this node will also have some address. Let's say its address is 1000. So that 1000 will be stored in your head. Head is a reference to the first node or which stores the address or which points to first node. Like this. Like this. Head just contains the address of your first node or it is pointing to first node. That's it. That's it. There is no other relevance of head. It just points to the first node. Okay. Now let's say. Now let's see how elements in list versus linked list are stored. Let's understand it in depth. Okay, then it will be more clear with the help of example. Let's say we have three elements again 10, 10, 20, 30, 40. Let's say four elements. How they will be stored in a list? Simply, a list will have a memory block where each element will be stored in a contiguous memory location like this on the index base. 10 will be stored at index 0, 20 will be stored at index 1, 30 will be stored at index 2, 40 will be stored at index 3. These are stored as index bases, and each element will be having your contiguous memory location. Like, for example, 10 is stored as 1000, 20 is stored at 1001, 30 is stored at 1002, next to each other, 10,003. And this will be your complete list. This is how your list will look like. Now, same elements, how they will be stored in linked list, guys. Let's see. 10 will be stored in a node 1. Correct. I will have to create 4 nodes because I have 4 elements. So I will have to create 4 nodes. Correct. 4 nodes. Right? This is my node 1. This is my node 2. This is my node 3. This is my node 4. And each node is having 2 parts: data, address of next node, data, address of next node, and so on. So, what is the data will be stored in node 1? 10. What is the data stored in node 2? 20. What is the data stored in node 3? 30. What is the data stored in node 40? Node 4, which will be 40. Right? And say address of node 1 is, let's say, we can say 5000. Address of node 2 is your 4000. It is not next to each other. It's just a dynamic allocation of the memory. Okay. Not next to each other. It will not be like 5000 and 5001. It can be anything. Can be anything. It can be even 5001, but it can be anything. Then node 3 can be your 6000, just a sample address. Node 4 can be your 8000. Like this. So in node 1, whose address will be stored? Node 2. So 4000 will be stored here, and node 1 will start pointing to this. Simply. This is because this is the reference of the next node. Then node 2 will point to node 3 because it will store the address of node 3 like this. Node 3 will point to node 4 because it will store the address of node 4 like this. Node 4 will not point to anyone because it will contain null as the address because this is the last node. This is the last node. So its address will be null. And who will point to the first node, guys? Who will point to the first node, guys? Head will point to the first node because head is just a reference variable containing 5000 or pointing to first node. That's it. This is the visual representation of your linked list. And when I say linked list, this is your singly linked list. This is your singly linked list. Singly. Why? Because each node is pointing to only one node, that is the next node. Node 1 is pointing to node 2. Node 2 is pointing to node 3. Node 3 is pointing to node 4. There are other type of linked list as well. Doubly linked list. Doubly linked list. We will see that as well. And circular linked list. But to give you an idea, in doubly linked list, node 2 will also point to node 1. Node 3 will also point to node 2, like this, in both direction. They will have both the direction. Okay. So not to confuse you guys, let me keep it very simple. Let me not cover this doubly and circular linked list now. But you got this. If I have 4 elements and in list, these will be stored in contiguous memory location. In the linked list, each element 10, 20, 30, 40 will be stored in a node. And in node, I will have your data and I will have your address. Node 1 will store address of node 2. So it will point to node 2. Node 2 will store address of node 3. So it will point to node 3. Node 3 will store address of node 4. So it will point to node 4. Node 4 will store null because it will not point to any node. And your head will contain the reference or address of your first node. And this is how your linked list will look like. Okay. Now, as we know the visual representation of both list, this is your list, and linked list, let's understand when we can use list and when we can use linked list. What is the actual difference? Actual difference of your list versus linked list. Very, very important concept of today's video. What is the difference between list versus linked list? We have already seen it. Now it will be very easy to tell you. For example, the first point, let me consider memory. Let me consider memory. And let me write here list and here it will be linked list. Now you yourself tell me what is the memory location for list or array? It is contiguous because it is next to each other. We have already seen it. We have already seen it. It is contiguous 1000, 1001, 1002, 10,003. And for linked list, 5000, then again 4000, then 6000, then 8000. What it is? It is random. Each node will be allocated memory randomly. Node will be allocated allocated memory randomly. So that's why in linked list the memory is random, and your list, it is contiguous. Now the second point is, guys, second point is, what's the size of the list? Size of the list. Size of the list is, guys, fixed. Size of the list is fixed. For example, of I agree that we can append and change the size. But for example, whenever we create a list or array, we specify that I want a list of 5 elements. Then all the memory block containing 5 elements will be allocated to you. Does not matter you store 1 element or 2 element. The entire 5 memory block will be allocated to you initially. So its size is fixed, but its size is dynamic. Linked list is dynamic. Why? Because when I create node 1, then only node 1 will be allocated memory. When I create this node, guys, then only it will be allocated memory. All the 4 nodes will not be allocated memory altogether. No. When node 1 will be created, node 1 will be allocated memory. When we will create node 2, this will see via code, then it will be created, it will be allocated memory. So it's dynamic. So it's dynamic as and when, node will be created. As and when node will be created, memory will be allocated. As and when node will be created, memory will be allocated. Okay. As and when node will be created, the memory will be allocated dynamically. But in list, we initially specify if I want to store 5 elements, so I will get the entire memory block of 5 elements of fixed size. Okay. So memory in list, it is contiguous. In linked list, it is random. We have seen 5000, 4000, and all. Size of list is fixed. Size of linked list is dynamic because each node will only get memory when they will be created dynamically. Now, access part. This is very, very, very important. If I want to access 20 in this list, I can simply write L of 1 because it is index based. It will give me 20. So, what is the operation I have to do here? It is just order of 1. Because I can simply access any element. If I want to access 40, I can simply write L of 3. This we have already seen, like in the list. But in a linked list, guys, as each of the node are linked, 1, node 2, node 3, node 4, without going to node 1, can I go to node 2? You yourself tell me. No. Why? Because node 1 stores the address. Node 1 stores address of node 2. Then how come without going to node 1, I can directly go to node 2? I cannot write linked list of 4000, give me this node 2. No. 4000, node 1 stores the address. And if I want to go to node 3, guys, what will happen? First, I will go to node 1. First, I will have to go to node 1. First, I will have to go to node 1. Okay, let me select some other color. First, I will have to go to node 1 and then to node 2. Because from node 1, I will get the address of node 2. And then from node 2, I will get the address of node 3. So I cannot skip any element if I want to go to node 3. Okay. So if I want to go to third element, how many operations would I did? 1, 2, 3. So I did 3 operations. So if I want to go to element 4, first I will go to node 1, then node 2, then node 3, then node 4. 4 operation. So similarly, if I have n elements, what will be my access complexity? It will be order of n because every element will be iterated. Every element will be iterated. Will be iterated. Why? Because each node Every element or slash node will be iterated because node 1 stores address of node 2, node 2 stores address of node 3, node 3 stores address of node 4. So if I want to go to from node 1 to node 3, if I want to directly go to node 3, can I go? No. I will first go to node 1 because it stores address of node 2. And then node 2 will tell me the address of node 3 and then I will go. So access is order of n, right? Now, you will say, then in memory also list is better, in access also list is better. Then why to use linked list? Why to use linked list? Like why? Why linked list? Why linked list? Now it will be clear. Now it will be clear, guys. Now it will be clear. Listen to me very carefully. Why? Because in case of insertion and deletion, fifth point, deletion, linked list is very, very, very fast as compared to list. Very fast. How fast? Order of one. Both insertion and deletion complexity in linked list is order of one, and in list it is order of n. Very, very important point when we talk about linked list, and that's why we have linked list. And this is the use case of linked list when we have a frequent insertion and deletion. Frequent insertion and deletion, always go with your linked list. Very, very important. Very, very important. Linked list is the solution because list is not made for that. Okay. Why? Let's understand it in depth. Okay. Because it's very, very, very important. And I like to cover everything in depth. No other video or tutorial will teach linked list you in depth like I teach. So do give it a like and continue watching this video to know more. Okay. Let's see. I have this list 10, 20, 30, 40. Now, I want to insert, I want to, here the indexes are 0, 1, 2, 3. Now, I want to insert one element called as 5 at index 0. I want to insert. Okay, I am talking about list first. List. What will happen? Firstly, 10 has to be shifted to 1, 20 has to be shifted to 2, 30 has to be shifted to 3, and 40 has to be shifted to the next index 4, so that this will be empty and then I will be able to store 5. How it will happen? I will have one more index 0, 1, 2, 3, 4. Hope are you getting this? Hope are you getting this? Now, if I want to store element 5 at index 0, I want to insert in list. Then what will happen? All the element will be pushed by 1. 10, 20, 30, 40. Then this index 0 will be vacant and then only 5 will be inserted. So do you see insertion is so tough in a list? Now suppose if I want to store in middle, then all the elements next to the middle will have to be pushed by 1. Then only the new element will be inserted. So that's why all the elements, and in maximum, the worst case I told you, if I want to insert at beginning or at beginning, then all the elements have to be pushed. Then on, that's why its worst case complexity is on. Simply, if I want to delete the very first element, suppose 10, then all the elements have to be moved one index ahead. Now, in case of deletion, what will happen? If I have deleted 10, then 20 will move to index 0, 30 will move to index 1, 40 will move to index 2. So, all the elements moved by 1, 1, 1, 1 index. So, that's why for insertion and deletion in burst case in list, the complexity is on. But now you will ask, but then why, how come linked list has order of 1? Now see the magic. Now see the magic of linked list. Now let's say the another same scenario 10, 20, 30. Like let's consider three elements for now for the better understanding. and it will have pointer to the next node. It will have pointer to the next node. It will have none at the last, and head will be pointing to the very first node. This we already know. And say suppose first node address is 1000, second node address is 2000, its address is 1500. So second node will store the reference of third node, and first node will store the reference of second node, and it will be have 1000 as the address. Now see this. Now if I want to insert one element, say 15 here, I want to insert at this point 15. I want to insert 15. Now tell me, will I have to move all the elements? No. I can do simply one thing, just one step operation. I can simply make this node point to this node. That's it. That's it. I will simply make this node point to this node. Say, suppose its address is 5000. I can simply point this node 1 to 5000. 2000 will be deleted from this. 5000, it will have the address and it will start pointing to the this node which I want to insert. And now this node which I have inserted, this will point to the next node which is your 2000, and it will start pointing to this. Simple. Insertion happened. Now your linked list will look like this. It will have 10, 10 will point to 15, 15 will point to 20, and so on. So did you see it's just one step process. No elements had to be shifted. I just made this node point to this and the new node point to the next node. Simple. Simple. That's why in linked list insertion is very, very fast. Very fast. And now let's consider the deletion as well. Now let's consider the deletion as well. Head is pointing to this. Now, if I want to delete this element, guys, will I have to shift all these by one, 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 one? No. What I can do instead, I can simply make my head point to the second element. That's it. So this will be my new linked list. Simple, and deletion happened with just the complexity of O1. And all these things we will see with the code as well, guys. All these things we will see with the code as well. So for linked list, the deletion and insertion is very, very fast, and its complexity is O1 when compared to list with O and ON. But for access, yes, I agree, list is very fast. We can do index based access in list, but in linked list we have to go sequentially, first node 1, then 2 and 3, and then so forth, right? So again, very, very important concept. Now, how can I explain you linked list in a practical example? I can tell you the practical example. Suppose you are playing a treasure hunt and you have a four clue one, clue two, clue three, clue four, and then finally you have the result at the end, and you will win. So you have to first find the clue one, right? You have to first find the clue one, and then only clue one will tell you about clue two. Then you, in a treasure hunt game, this is what we do. And then your clue two will tell you about clue three. And then your clue three will tell you about clue four. And then finally you will get the result. You cannot simply jump from clue one and then you can go to this with skipping clue two, clue three, clue four. This is not possible, right? So that's why in linked list also, you cannot jump to any element. You have to go in a sequence. You have to start with node 1. You have to go to node 2 because node 1 contains address of node 2. Node 2 contains address of node 3, and then finally it will have pointing to null. Simple. This is the practical use case of your linked list. And we saw what is a linked list, what is data structure, what is the difference between your list and linked list. Having said that, it's time to create our first node. Creating our first node object. Creating our first node object. Very, very important. Very, very important. Why? Because node is a class. Okay. Unlike list, list is a pre-built data structure. Pre-built data structure. Linked list is not pre-built. List is pre-built. Linked list is not pre-built. We have to create ourselves node class. And how to create node class? This I am going to show you now. And we know node will have two things: data and your address. And this address generally is represented by address or a variable called as next. We will create it now. And this is your node. And we will create object of this node class and we will see how it looks like. Okay. Are you ready? If you are ready, let me go to my pie chart. This is my linked list program. What I can do. And now for this guys, please go and revise object oriented programming lectures which I have uploaded and which is there in my course as well, which you can find at bigdatayatra.com, where we teach data engineering and cloud mastery. Let me just show you a quick sec. This is my Instagram page where I upload daily reels, and this is my website www.bigdatayatra.com. Here you can simply check all the data engineering and cloud mastery course. You can go to the curriculum. All these are the curriculum in Python and data structures. I have all these linked list, stack queue. Then we have object oriented programming as well. And then we have SQL, Spark, Azure Fundamentals, Databricks, Data Factory, everything. Or you can just simply come to bigdatayatra.com. You can book free 101 call with us. Just enter your detail. We will get in touch with you. Now it's time to create our first node. So what I can do is I will name it as class node. And now what is class? It's just a blueprint of how your object will look like. But in depth, if you want to know, you can refer object oriented programming lectures, which I have already covered. Now I will create a constructor, guys, which will call by itself whenever I will create object of this node class. Okay. And the self represent current instance variable, current object, right? Self represent current object. And this is a by default argument which will get passed whenever we will create object of node class. So all these things you should know. So I will give data here as the second argument because I need data. So if any object will call node class, right, or it will any object of node class will be created. So data will be stored in that. And the second thing, what I need to store, second thing is address, right? Can I make address of this node with the variable name called next? For now, let's see the next as none. Next as simple. This is my node class. That's it, guys. This is my node class. Simple, easy to understand, very easy peasy. So this is your node class. I have two things: data and the address. This we already saw. Like a node will have your two things: a data right here and your address. So that's what I created. Now it's time to create object of this node class. So can I do this node one, node of 10? So this will be my very first node called as node 1. Simple. Simple. Node 1. Let's print this. Print node 1. What it will print? It will print the address. It will print the address. Why? Because node is just a class, right? It will not print 10. Guys, it will not print 10. Don't get confused. Don't get confused. Many people will get confused. What has happened here currently? I have just created a class node in which in the constructor in it I have mentioned I need two things: data and I need next, which is the address of next node. So when I will create the object of node 10, data will be 10, but node 1 will contain address, or the any variable will just point to this node. It is just a pointer to this node. Okay. It will be more clear. Or we can call it as a head also. We can call node 1 as head also because it will point to the first node. Okay. Let me call head. Now let's run this. You will see this is the address where this node is stored. Till now, what has happened? Till now, what has happened? Okay. After this point, what has happened? Let me just copy this code. Let me go. All these things are very important to understand, guys. Very. That's why I'm taking so much time to explain you guys. What has happened when I have created this node of 10? So a node will get created, right? Like this, a node will get created and it will have 10 in the data. Currently address, I have not added anything in next, so it will have none for now. For now, it will have none. And then its address, right? Whatever the address is, you can see I have printed this 101566. 101566. Let's see, let's consider this 101566. This is the address. So what I have done, will not head will not point to this data. Head will point to this address instead. So head is pointing to this. This is the current structure after till this point. Now I need to create another node. I need to create another node having 20, and this node 1 will start pointing to the node 2. Let's see. Let's see how to do that. This is my head node. Now this node 1, which I have created, will point to your node 20. This is the another node, node 2. Okay. This is the another node called node 2. Head is pointing to the node 1. And this is another node called node 2. And my head now will point to my node 2, or this node 1 will point to my node 2. Okay. If head is confusing you right now, let me just do node 1 for now. This is my node 1. This is my node 2. This is my node 2. Let me just print. This is my node 1 address. This is my node 2 address. Right? Simply let me create a node 3 as well. Node 30. And then I will print node 3. So the address is done, done, done. Three nodes, three address. Right? Node 1, node 2, node 3. Now node 1 next should point to node 2. Correct? Right. So what I can do, can I write simply like this, node 1 dot next equal to node 2? Simple. And then node 2 next should point to node 3. Can I write like this? Can I write like this, guys? Do you agree? Do you agree? Node 1 data is 10. Node 2 next is node 2 address. So that's why it will point to node 2. Node 2 will point to now node 3. Simple. Correct. This is my linked list. I have created this. Let me just remove this. Simple. Or can I do like this? This is my node 1. Or can I do, instead of making it in two step, first I'm creating node 2 and then assigning node 1 dot next to node 2 to node 1 dot next. So can I simply write like this? Can I not simply write like this, guys? Simply node 1 dot next. Simple. And can I not like this for node 3? Node 1 dot next dot next. Simple. Simple. These are my three nodes. I have created the data and I have stored node 1 will contain the address of node 2, and then node 2 will contain the address of node 3. Simple. This is how we create our node class, if it is clear. Or you can do simply like this as well. Head will be containing the address of node 1. Then head dot next will be what? The node 1, right? So head dot next will be node 1. So node 1 will point to your node 2. And then head dot next will be your node 3. Simple. These are my three nodes. Simple. Now, if I want to print the data, I will do print head dot data. It will print 10. See. Now, if I will do print head dot next is what? Head dot next is what? Node 2. So head dot next dot data, it will print the node 2 data 20. Then if I will do print head dot next, which is node 2, dot next, which is node 3, dot data, it will print the data of node 3. Simple. Simple. Right? And if I want to print head, if I want to print just head, it will print the address of node 1. It will print address of node 1. And if I do head dot next, it will print address of node 2. If I just print head dot next, it will print the address of node 3. Simple. I hope it is clear. I hope it is clear, guys, what is happening. See, first the address is getting printed and then the data is getting printed. Let me just copy all in a notepad and explain you once for all and clear all your confusion. What has happened first? Simple C. I have created a node class. Till this point, I hope it is clear. This is the very first object which I have created of node class. So what it will happen? What will happen is node will be getting created. Node will get created, and its data will be 10. Its data will be 10, and it will have some memory address. It will have some memory address, right? Dynamic memory location. This 100196, 100196. 100196, head will start pointing to this. Simple. Right? Now, if I do head dot data, what it will be print? You yourself think, right? Head is pointing to node 1. So node 1 dot data, right? This 10. So 10 will be printed. Now, if I do head dot next, here, here. If I do head dot next, it will be address of node 2 because it will store the address of node 2, right? So head dot next, what I'm doing? Node 20. So 20 will get created and whatever the address is, see, whatever the address is, 100 BC. Okay, 100 BC. Its address is 100 BC and then it will be stored here. 100 BC will be stored here. So no head dot next will be 100 BC. Simple. And now, head dot next is this, which is pointing to my node 2. The head dot next will be what? Node 2 ka address. That is node 3. Head dot next. It is the address of node 2. Dot next. It will be address of your node 3. Node 3. 30. It will be address of node 3. So head dot next will print the address of node 3. Simple. This is how a linked list works. If I want to go to node 2, I will go to head dot next first. That is the address of node 2 is stored in head dot next. Head is the first node. Head is the first node, or head is just a reference variable pointing to the first node. This is your first node, right? I hope it is clear. Practice it, watch it again and again. We will come up with a lot more program in the next video where I will explain you all the operations of a singly linked list. Then I will explain you doubly linked list and circular linked list as well. And along with that, all the important lead code questions will be given. Thank you so much. See you in the next video.